Okay, this is Algebra 2, Set 83, variable expression. No, variable exponents. Okay, let's get started. Okay, so the first thing we're going to do is review exponents, the rule of exponents. So if we have something like x squared times x to the fifth, we can picture it as putting all of the x's out there and then counting them up. You have 2 and then 5, so we know the answer is x to the sevenths. So the rule then is if you have x to the a times x to the b, the answer is going to be x to the a plus b. So let's do some examples. First of all, we need to simplify this expression. So the first thing that we're going to do is we're going to look for the common bases. So we'll take the x's and we'll put those together, and then we'll take the y's and we'll put those together. So the x's, we have x to the a and x to the a over 2. Then we'll group the y's, y to the 2x and y to the 3x over 4. Now we're going to put those together. So again, using the power rule or the rule of exponents, we are going to take a and add it to a plus 2, and then we'll do the same thing with the y, 2x plus 3x over 4. Okay, the next step is to add those. A is the same as 2 over 2a, so 2 over 2a plus a over 2 is going to give us 3a over 2. Then we'll do the same thing with y. We'll get a denominator of 4, so it becomes 8x plus 3x over 4, which becomes 11x over 4. So when we put it all together, x to the 3a over 2, y to the 11x over 4. Okay, next example. Simplify this expression. So the first thing that we're going to do is we're going to get rid of that denominator, bring everything up to the top. So we'll have x to the a minus 2 times x to the negative a over 2. Then we'll bring that y to the 2a up, y to the a plus 4 times y to the negative 2a. Again, when you bring something from the denominator, it takes a negative exponent. Okay, the next thing that we do is we're going to add those exponents together that have common bases. We'll look at the x's first. So I rearranged the order a little bit. We have a minus a over 2, just brought that over, and then subtract that negative 2. Then we'll do the same thing with the y's. We brought that negative 2 and put it with the a, so we have a minus 2a plus 4. Next step, simplify that. So we didn't do it, but 2 over 2a minus 1 over 2a becomes just 1 over 2a, or a over 2, minus 2. Then for the y, a minus 2a becomes negative a, and then just bring that plus 4 over. And that is your solution. Okay, next step is we're going to just briefly review the power rule. You have x to the third squared, which means you have x to the third times x to the third. And again, using the rule that we just used, if you have two powers with the same base, you're going to add those. So x to the third and x to the third becomes x to the sixth. If you come back up and look at x to the third to the second, the way that you get that is x to the 3 times 2, which is x to the sixth. So the rule, if I have x to the a raised to the b power, is x to the ab. Just a quick review there. Okay, simplify. So if we're going to simplify this, the easiest thing to do is just multiply those two powers together, and we're just going to distribute x to the 2a plus 4. That's your solution. Now we'll go a little bit harder. So the first thing that you need to do with this problem is get rid of the denominator, bring x to the negative a up with the rest. So we'll have x to the ab, and then when we bring it up, it's going to lose that negative, so it becomes x to the a. Now we'll look at the y's. There aren't any y's on the bottom, so we're good. We'll probably just rewrite it and distribute. So a times b and a times 2. So you get ab plus 2a. Okay, then we can just write them all with one base, x to the ab plus a and y to the ab plus 2a. And that is it. Good job.